All right, class, settle in, settle in. Today, we're going to pull back the curtain on how we really measure sight. We're moving beyond the basics you already know and diving into the precision tools that, honestly, define modern vision science.
Now, you've all heard the term 20/20 vision. Of course you have. It's everywhere. It's become this cultural shorthand for, perfect eyesight. And the definition seems simple enough, right? You can see clearly at 20 feet what an average person sees at that same distance. But is that all there is to it? No way. As future clinicians and scientists, your understanding has to go so much deeper. That simple little fraction, that's just the cover of a much more rigorous and, frankly, much more fascinating story. So let's turn to page 1. We're going to start with the instrument that actually gave us 20/20, that classic eye chart. And we're going to see why, even though everyone knows it, modern science really demanded something far more precise. So this is the Snellen chart. It was developed way back in 1862, and its design is, well, it's iconic. But look closer. I mean, really look. See how the number of letters changes on each line? And the spacing between them and between the rows? It's not mathematically proportional at all. Now, for a quick screening, sure, it works. But for serious research, for tracking those tiny, subtle changes in a patient's vision over time, these inconsistencies, they're a real problem. To solve these problems, vision scientists in the 20th century developed a much better tool, one that wasn't based on convention, but on pure mathematics. And this is where we introduce the LogMAR chart. So picture this. It's 1976, and two researchers down in Australia, Ian Bailey and Jan Levy-Catney, they set out to fix the flaws of those old charts. Their goal was simple, but it was also profound. They wanted to standardize the entire task of reading letters on a chart to make every single step of the test consistent and repeatable.
And this quote from their original paper, it really says it all. This wasn't just about coming up with a new design. It was about creating a whole new standardized principle for measuring vision. They were bringing true scientific control to the eye exam. Now, I know the name LogMAR can sound a little intimidating, but once we break it down, you'll see it's actually brilliantly descriptive. So let's decode it piece by piece. Let's start with the MAR. It stands for the minimum angle of resolution. It's the scientific term for the absolute smallest detail your eye is capable of resolving. You can almost think of it as the pixel size of your vision. A smaller MAR means sharper, clearer sight. Simple as that. The log part simply means we put that MAR value on a logarithmic scale. Now, why on earth would we do that? Well, because using a log scale ensures that the change in letter size from one line to the next is perfectly, mathematically proportional. Every single line on the chart represents an equal step in visual challenge. No more guesswork. Okay, this table here, this is where it all clicks. Look at how we translate the old system into the new one. So perfect 20/20 vision corresponds to a minimum angle of resolution of 1. And since the logarithm of 1 is 0, 20/20 vision is a logMAR of 0.0. See? Now, if vision gets worse, say to 20/40, the MAR doubles to 2, and the logMAR score becomes 0.3. It's just pure, elegant math. And this brilliance, it extends to the scoring too. You're no longer just marked on the last full line you managed to read. With LogMAR, every single letter counts. So if a patient reads the 0.3 line, and then they get 3 more letters on the next one, their score isn't just 0.3. No, it's 0.3 minus 0.06, giving them a super precise score of 0.24. This level of detail is absolutely critical for tracking disease progression. So let's do it. Let's put these two charts right next to each other, side by side. When you see the design differences laid out this clearly, the advantages of the LogMAR system become, well, they become undeniable. And there it is. This just illustrates the point perfectly. On the left, you've got Snellen, variable, irregular, inconsistent. On the right, LogMAR, 5 letters on every single line, proportional spacing throughout, and it even uses special letters called Sloan letters that are specifically designed to be equally difficult to read. It standardizes everything. It's a game changer. Now, all of this might seem like a purely academic exercise, but I promise you, this kind of precision has a massive impact on people's lives. It's how we define impairment, and it's how we track if the treatments that can save a person's sight are actually working. Okay, this is the most crucial mental shift you need to make today.
While the Snellen notation describes acuity, what you can see, LogMAR notation is really a measure of vision loss. A score of 0 is the baseline, right? That's 20/20. Any positive number indicates vision that is worse than standard, and the higher that number gets, the more significant the loss of vision.
And this is where it gets very, very real. The World Health Organization uses this exact scale for its official definitions. A best corrected visual acuity that's worse than 0.5 logmar in the better eye. That is the international standard for what we call low vision. It's a specific, data-driven threshold. And if that score climbs higher, to worse than 1.3 logmar, that is the WHO's definition of blindness. These aren't just arbitrary lines we draw. They are precise measurements on a standardized scale, and that precision is only possible because of the LogMAR chart. This changes lives, and it changes public health policies.
So let's recap the lesson real quick. We've established that the good old Snellen chart has some critical design inconsistencies. The LogMAR chart corrects for all of those, offering a standardized, truly scientific measurement. Its logarithmic design allows for incredibly precise scoring. And maybe most importantly, this precision is the vital standard used all around the world to define low vision and blindness.
So I'll just leave you with this thought. The switch from a simple, conventional chart to a logarithmic one completely changed how we see sight itself. It makes you wonder, doesn't it? What other invisible scientific standards are out there, quietly and precisely shaping the world all around us? Class dismissed.